Hello everyone, welcome you back for the sessions on the ideal viscosity. In continuation with respect to the previous session, what we are discussing is with respect to the hydraulic fluids, that too especially the ideal viscosity. As you know that a low viscous fluid is thin and can flow easily, whereas the high viscous fluid is thick and it cannot flow easily. Then the viscosity of the fluid should be high enough to seal the working gap between the parts and prevent the leakages, but it should be low enough to cause easy to flow throughout the system. The high viscosity fluid requires a high energy to overcome the internal friction, resulting in the excess of heat generation. On the other hand, the low viscosity fluids flow easily but causes a leakages and reduces the volumetric and as well as the overall efficiency. Therefore, the hydraulic fluids should have an optimum viscosity and temperature resulting from the leakage and as well as the losses. The next topic what we are discussing is with respect to the additives what we are adding into the fluid to increase the life and as well as the efficiency of the oils or the fluids what we are using in the fluid system. The various types of the additives what we are adding to the fluid to sustain, and the important characteristics are the anti-foaming. They are added to reduce the foaming of the fluid. As you know that the fluid what we are using in the system will be under high pressure, and also it will be under working condition and also in the circulatory motion in a closed loop system. As it starts moving the oil, there is a chances of forming a foams. These foams should be removed or it should be minimized, and if the same air bubble starts entering into the system, automatically the efficiency of the system will comes down. The anti-wear, the wear resistance chemicals are added to the fluid to protect the critical hydraulic components from wear. The corrosion inhibitors, the chemicals are added to protect the surface from the chemical attack by the water. As we know that the water is one of the contaminant which is coming in contact either by through the atmosphere or by the disintegration of the chemicals which is nothing but the oil, and there may be a chances of formation of the vapors. As we know that the systems it will works at high temperatures. Because of this, there may be a water inclusion into the oil. Once if the water starts including into the oil, as most of the systems and as well as the system components what we are using is of iron or it may be the ferrous materials, these materials may start corrode. Biocides, the emulsifying chemicals are added to the fluid to inhibit the growth of the waterborne bacteria. Once if the water starts accumulating or coming in contact with the oil, along with these the waterborne bacteria like either it may be the algae, these can also come or they may grow in the reservoir, by which automatically the efficiency of the system will reduce. To avoid that, normally what they're using is nothing but the biocides. The emulsifiers is also added to facilitate the formation of the stabilization of the emulsions. The lubrication oiliness agent. Extreme pressure agents are added to the fluid to enhance the lubrication characteristics for the effective full film boundary lubrication between the two mating parts. See why this lubrication oiliness agents are required means, as we know that the system is working at high temperatures and also high pressures. Once if it starts working at high temperatures and as well as a high pressure, there is a chances of losing the viscosity. Once if the viscosity starts decreasing it, the fluid film boundary lubrication will also start decreasing it. To have a uniform fluid film boundary lubrication between the mating parts, lubrication oiliness agents are added. Then the flocculants. The flocculants are the chemical added to dispersion of the solid in a liquid to combine a fine particles to form a flow or a small solid masses in the fluid. Deionization. The elements which provides the hardness, like either it may be the calcium, magnesium, iron, aluminum salts, are removed through the deionization of the water. See, once ever the water starts coming in contact with the lubricating oil, or it may be the system oil what we are using in the fluid systems, along with the water, there may be a chances of coming in contact with the calcium, magnesium, iron. Along with these, even the chlorine, fluorine, and some other salts are comes in contact with the oils. These salts, or it may be these salts, may increases the viscosity, or these salts may come in contact with the other ferrous material, by which the wear and tear can also be increases. To avoid that, deionization additive agents normally we are adding into it. The oxidation inhibitors, anti-oxidation additives are added to provide antioxidation characteristics. The oxidation changes the chemical characteristics of the fluid. The vapor phase inhibitors. Vapor phase inhibitors prevents the oxidation or the corrosion of the metals in contact with the vapor phase of the fluid, in ensuring by the addition of the appropriate chemicals. See, these are all the some of the additives which has to be added to improve the efficiency of the hydraulic fluids. The next part is with respect to the selection of the hydraulic fluid. As we know that the major four primary functions of the fluid is to transmit the power, lubricate the moving parts, sealing the clearance between the mating parts, and as well as the dissipating the heat. Some of the what important properties which are essentially required are good lubricity, ideal viscosity, chemical stability, compatibility, etc. These things should be a must, by which automatically the efficiency of the system can be increased. The next topic what we are discussing is with respect to the effect of temperature and as well as the pressure on the hydraulic fluids. The viscosity is the most important property of the hydraulic fluid. The temperature has an advanced effect on the viscosity of the hydraulic oils. Hence, it has to be seen that the operating temperature of the hydraulic system is kept reasonably a constant level. Otherwise, there will be a tremendous loss in the system, which will reduces the overall efficiency by changing the viscosity.